Let's start now. Number 10. Isolated star systems, the cosmic solitude that shapes worlds. Imagine a sky with only one sun. Stable, silent, and absolute. No other star interferes. No external force disturbs it. It seems perfect. But that perfection comes at a price. Isolated star systems are the simplest in the universe, and for that very reason, the most predictable. Everything revolves around a single star, creating billions of years of almost uninterrupted stability, and that's exactly what allows something rare. Enough time for life to emerge and evolve. Without constant chaos, complexity has room to grow. But here's the problem. Everything depends on a single star. If it fails, everything ends. No warning, no alternative. When that star ages, expands, or collapses, the fate of every planet is sealed. This is the paradox. The safest systems is also the most vulnerable. Number 9. Binary systems. Two suns, a balance in motion. Now imagine looking up at the sky and seeing two suns. Binary systems are more common than you might think, and far more unstable than they appear. Two stars orbit each other in a delicate balance, where any disruption can change everything. Gravity here doesn't come from one source, it comes from two. And that changes the entire game. Planets may orbit one star, or both at the same time. This creates unpredictable days, irregular seasons, and a sky that is never the same. In some cases, these stars get close enough to exchange matter, as if they were slowly consuming each other. And yet the system doesn't collapse. It adapts. Here, the universe begins to reveal something important. Balance is not the absence of conflict. It is the ability to survive it. Number 8. Three-star systems. Complexity sustained by chaos. Three stars in the same system. It sounds impossible to keep stable. Yet the universe makes it work, at least for a while. These systems exist on the edge between order and chaos. Typically, two stars remain close while the third orbits at a distance, a natural attempt to avoid collapse. But there's a problem, the so-called three-body problem. Small initial changes can lead to massive consequences. A tiny shift today can destroy the system millions of years later. For any planet there, stability is never guaranteed. The sky may change, the climate may fluctuate, the future is uncertain, and still, some of these systems survive for billions of years. This reveals something surprising. Chaos doesn't prevent order. Sometimes it sustains it. Number 7. Complex multi-star systems. The architecture of the unpredictable. Now increase the number of stars, and everything spirals out of control. 4, 5, 6 stars, all pulling on each other at once. There is no clear center, no simple stability. Here the system doesn't follow easy rules. It evolves in real time. Small differences at the beginning can completely reshape the future. One star may be ejected. Another may form a new pair. Everything can reorganize. For planets, this is almost a sentence of chaos. Orbits break. Worlds are thrown into interstellar space. Entire systems unravel. And yet, some still manage to survive. That's the most astonishing part. Even in extreme chaos, the universe still finds ways to create patterns. But here, one rule is clear. Nothing is permanent. Number 6. Red dwarf systems. Persistence on a cosmic scale. Now think of something completely different. Small, dim stars that almost never die. Red dwarfs don't stand out because of brightness, but they dominate the universe in numbers. And here's the astonishing detail. They can live for trillions of years. Trillions. That means one thing, more than enough time for life to emerge. Maybe more than once. But there's a darker side. To stay in the habitable zone, a planet must orbit extremely close to the star. This creates a strange effect. One side of the planet lives in eternal daylight, the other in total darkness. And as if that weren't enough, these stars can unleash violent flares capable of stripping entire atmospheres. Even so, these systems remain among the strongest candidates in the search for life. Because in the universe, those that last longer get more chances. Number 5. Blue giant systems. Energy in its purest form. Now, we move to the opposite extreme. Blue giants are massive, brilliant, and they burn out far too quickly. They release energy at an absurd rate, lighting up space with almost unimaginable intensity, but that intensity comes at a cost. They die young, very young. In just a few million years, it's all over. Planets around them rarely have time to develop life, and if they try, intense radiation may wipe out any possibility. But the true spectacle comes at the end. When a blue giant dies, it explodes in a supernova, releasing more energy than an entire galaxy for a brief moment. It is beauty and destruction at the same time. Here, the universe reveals its most extreme face. Number 4. Post-Supernova Systems. Reconstruction after collapse. After the explosion, you would expect silence. The end. But that's not how the universe works. Instead, something new emerges. What remains can collapse into a neutron star, an object so dense it defies comprehension. And the most surprising part, some planets survive. They continue orbiting, but now in a completely different environment, dominated by extreme radiation and intense forces. These systems are cosmic scars, marks of a violent past that didn't erase everything. They prove something fundamental. The universe doesn't just destroy, it rebuilds. Even after collapse, the story continues. Number 3. Black hole systems. Gravity at the absolute limit. Now we arrive at one of the most extreme places in the universe. Black holes. Regions where gravity is so strong that not even light can escape. It seems impossible for anything to exist there, and yet it does. Stars can orbit black holes. Even planets can survive, if they stay far enough away. Around them forms a superheated disk of matter glowing with immense energy. Space bends, time slows, reality itself changes, and still, orbits continue to exist. That's the most surprising part. Even at the limits of physics, structure remains. Here, the universe pushes its own boundaries and keeps going. Number 2. Star cluster systems. Constant interaction. Now imagine thousands of stars, all packed close together. This is a star cluster, an environment where isolation doesn't exist. Here, encounters are inevitable. Stars pass close by. Gravities collide. Systems are constantly altered. Planets can be captured by other stars, or simply thrown into the void. Nothing is static, everything is in motion. But this is also where many stars are born. Chaos and creation exist side by side. These systems are like cosmic cities, crowded, dynamic, and full of interaction, and within them, stability is always temporary. Number 1. Galactic-Scale Systems, the ultimate structure. Now zoom out much further. Billions of stars, trillions of planets, all connected in a single structure, a galaxy. Here, every system is part of something greater. Nothing is truly isolated. A system's position within the galaxy can shape its entire destiny. Central regions are chaotic. Outer regions are calmer. Everything orbits. Everything moves. Everything is connected. This is the highest level of organization we can observe. And once you realize that, an unavoidable question emerges. If everything is part of something bigger, where does it end? Spoiler, it might not.